Good evening everyone, welcome back to DSA Buddy. Today is 15 March 2023. We are going to do question number 958, check completeness of a binary tree. Before moving on with the question, I request you all to please hit like, share and subscribe. It motivates me a lot. So now move on to the question. Question is saying we are given a binary tree and we have to determine if it is a complete binary tree or not. What is a complete binary tree? Every level except possibly the last level is completely filled and all nodes in the last level are as far left as possible. It can have between 1 and 2h nodes inclusive at the last h level. What it means is, if you are given this example, every level should be complete. Okay, that everyone should have complete, and if it is not complete, then it should be the last level. And in the last level, we should always fill the leftmost nodes first. Then we can fill the right one. So in this case, when we see the levels, it is complete, and the last node is incomplete, but everyone is filled from left side and only right one is null. So the answer to this one is true. But if we see the second example, in the second example when we see it, first is filled, second is filled. In the third example, it is not filled from left side. These two are filled, but this is null and the right one is filled. So it is not a complete binary. In that case, you will return false. If both of these were null, then you could have returned true because everyone is filled from left. Okay. You cannot fill a right position before the left in the last level. That is the case for a complete binary tree. So how do you actually approach it? For a tree or graph questions, what we have for traversal is only two algorithms majorly, that is BFS and DFS. BFS is breadth first search and DFS is depth first search. So if you have to check level by level, which level algorithm will you prefer? Obviously BFS because it is also level order traversal. So you will go level by level and check whether it is completely filled or not. But inside the BFS you have to check how you can check that whether they are filled from left or not. How can you verify this condition when there is null here and after that there is position? So for that, see this example. Values are not considered because they don't make a difference. When you see the example, it is filled. Let's say there is another node, it is also filled. Okay, but for BFS, the special condition only will be whenever you encounter a null value. Let's say here is null. If you encounter a null value, after that every value should be null. It is null, it is null, and it is null. Every value should be null after that. But if you encounter a node here, let's say 6 value, then in that case you will return false. Why false? Because you encountered a node which is not filled from left side and that violates the condition for a complete binary tree. That is what you had to do. After you encountered a null, every next node should have its children as null. That is what you have to do. Suppose in this case, if this was null as well, that won't make a difference because you encountered a null and after that there is another null. Let's see this case. If you encountered a null here and you are encountering a value here, that is 7 in this case, that returns a false. But in the first case, if you encountered a null here, after that everything is null. So it returns a true. So that is all you have to do. It is Leetcode medium, but it should be Leetcode easy. So let's just zoom it for you and let's start coding. For coding this, we will start with making a queue. If you are not clear about BFS, check out my other videos. I have explained BFS so many times that it should be on your tips now. So we will make a queue and its data type should be tree node and we will name the queue as queue. We will push our data root inside it. After that, what we will do? While queue is not empty, what we do? We get the size of the queue, that is queue dot size. After that, while this size is not empty, we will start iterating. How we will start iterating? We will get the front value, that is, let's name it as node is equal to queue dot front. We will get the front value and we will start popping. That is what you do in BFS. And to check the condition when null starts, let's create a variable flag. Let's initialize it with false. Now what we do, if we encounter any node as null, node value as null, we will make our flag as true. Okay, and if any node is not null, what we do? We simply push node left and node right to our queue. That is what you do. But also you have to write a if this flag becomes true, that means you have encountered a null value, and after the null you are still getting a node value, which should not be possible. If the flag value becomes true, you will return false. Okay, and if this is not the case, ultimately if you exit the BFS call, you will simply return true. That is all you had to do. What is mean by this? That suppose in this example, when you have your flag as false, okay, and you encountered a null value here, so your flag changes to true. But after that there is a value 7 existing. That means node exists but flag is true. So that is violating your condition and you will return false at that very moment. That is all you had to do. Okay. So that is what we have written. Let's just submit it. So yeah, it is accepted. So the time complexity and space complexity in this case will be O of n, as we are applying BFS. I hope you liked the video. Please hit like, share and subscribe. It motivates me a lot. Thank you so much for watching. See you in the next video. Bye bye.